So converse. The converse is taking the statement and exchanging the hypothesis and the conclusion. Switching your hypothesis and your conclusion. So we said yesterday, if it is raining outside, then the ground will be wet. We would switch that and say, if the ground is wet, then it's raining outside. So it switches your hypothesis and your conclusion, which means your symbol switches. Now we're saying Q implies P. So my converse would say, if Q, then P. So we switch it. Q, arrow, P. Now your conditional statement can start out true, but when you switch it, become false. It could start out false, and then when you switch it, it becomes true. So the truth value does not follow based on what kind of statement you have, okay? Inverse is our third kind of statement today. The inverse is going to negate the original conditional. It's going to negate the original conditional. Lexus, put your phone away. Okay, like out of the way. Thank you. The inverse is going to negate the original statement. So it's going to add in those words not, don't, can't, won't. It's going to do it to both the hypothesis and the conclusion. So it negates your hypothesis and your conclusion. So it's going to say, if not P, then not Q. Your symbolic notation will be squiggly P, arrow, squiggly Q. So that would say something like, if it is not raining outside, then the ground is not wet. So you're just adding in that not, won't, can't. Now, it may be that the sentence already has those words in it. So then if you negate it, you're actually taking them out of the sentence to change it. Does that make sense? So if Edwin does not wear a white shirt today, then Edwin does not wear a white shirt every day. We could switch that and take out the words not and say if Edwin does wear a white shirt today, then he does wear a white shirt every day. So if the words are already in it, you take them out to negate it. If the words are not in it, you put them in to negate it. Okay? The fourth one is called the contrapositive. And the hardest part of this is memorizing which one goes with which. Okay, you're going to have to know, what does the inverse do? What does the converse do? What does the contrapositive do? And they won't be in order all the time. So you're going to have to memorize what those are. Contrapositive does both. It takes the original conditional and it switches the hypothesis and the conclusion to give us the converse, but then it negates that converse to give us the contrapositive. So it switches and negates. So it does both. Okay, it does the converse where it switches and it negates the converse. So it's going to say, if not Q, so we're switching, then not P. Okay, so it's going to switch and negate. So that means over here we're going to have squiggly Q, arrow, squiggly P. Okay. So if we go back to our original statement we said yesterday, if it is raining, then the ground will be wet. We're going to say if the ground is not wet, then it is not raining. So it switches and negates. The contrapositive does both. It negates the converse because the converse is already switched, so it negates the converse. Does that make sense? Okay, so converse switches, inverse negates, and they do that to the original conditional. The contrapositive does both. It switches the original and negates. Conditional is your original. There's one more that we're going to learn called the biconditional statement, but it's going to be a little bit later. So we're going to practice these four first with this example. And I'm going to write it on the board over here, matching it up with these four, okay? So it says write the converse, the inverse, and the contrapositive of the conditional statement. Then use the science fact to find the truth value of each of those statements. Here is your science fact, okay? So this is your original conditional. If an animal is an adult insect, then it has 6 legs. Okay? So first of all, what's the hypothesis? Careful. Okay, don't include the word if. An animal is an adult insect. There's your hypothesis. What's your conclusion? It has 6 legs. Don't include the word then. Okay, so when you're doing this, when you do your converse, you're going to switch those. But remember, you're never going to start your sentence with if it, if they, if them. You're going to identify your subject. Okay? So help me out. What is my converse going to say?
Just said don't put it in.
Okay, so what word do I start with for sure? If, because I'm writing it a conditional statement as a converse. Okay, so what is the subject here that we're talking about? We're talking about insects, but they are a type of animal. This is the broad topic, animal. So when you start your sentence, you're going to start with if, but you can't say the word it, and it refers back to the animal. So if an animal, then go on with the rest of your conclusion because we're switching. So if an animal what? Has 6 legs, comma, then it, you can write it there because you've already defined your subject. Now we know what it is. It is the animal. Does that make sense, Javi?
Yeah.
Okay. Say it again, Karina. It is an adult insect. Okay, so you guys with me? Start with if, define your subject, whatever that broad term is that represents your subject, and then finish your sentence with the original hypothesis. So if conclusion, then hypothesis. Just switch for converse. All right, let's do inverse next. Inverse. So the inverse takes the original statement and does what? Negates it, adds in the words not, don't, won't, or takes them out if they're already there. So we'll start with if, what? Very good. If an animal is not an adult insect, comma, then, very good, it does not have 6 legs. So everybody with me there? Original statement stays the same, but we just add in those words not, don't, won't. Okay, third one is our contrapositive. It's really the fourth one, but we already had the conditional given to us. So the contrapositive is going to take the original one and do both. It's going to switch and negate. So what do we start with? Careful, don't start with if it's. If an animal. Good, so now we're coming down here to the end, but we're negating. So if an animal does not have 6 legs, comma, then it is not an adult insect. I told you, this is going to be a lot of writing, this first part. It's going to get a little better, but today is massive writing, I promise. I'm not lying to you, I know it will be. It's going to be a lot. Make sure you're identifying the parts as you write them, okay? All right, you guys are going to read that science fact and decide, are those true or false statements based on your science fact? Okay, so all of them. It said, find the truth value of each. So you're going to start with the conditional. Is it true or false? Then go to the converse, true or false, inverse, contrapositive. Go ahead, talk it out, we'll compare. So our science fact says that adult insects have 6 legs. So every adult insect has 6 legs. No other animals have 6 legs. No other animals, okay? So if an animal is an adult insect, then it has 6 legs. True or false? True. Okay, come over here. If an animal has 6 legs, then it is an adult insect. No other animals have 6 legs, and adult insects have 6 legs. So if an animal has 6 legs, it must be an adult insect. So it is true. Okay? If an animal is not an adult insect, then it does not have 6 legs. If it is not an adult, okay, but it says no other animals have 6 legs, right? So if it's not an adult insect, then it does not have 6 legs. I get what you're thinking about baby insects, but we're just going to say maybe those baby legs don't grow till later. That's why they're saying only adult insects, okay? So true. Contrapositive. If an animal does not have 6 legs, then it is not an adult insect. True. Okay, this is not a good example to use to show you this last part of our notes, so I made up another one that will be a good example. So, if you make a 90%, then you make an A. True or false? True. Okay? We're going to go through this pretty quickly, so I'm probably not going to give you time to write it all down, but just listen and pay attention. Let's switch it to do the converse. So if you make an A, then you make a 90%. So notice that it switched, right? Because you can make an A and make a 100, 97, 89.5. So, that's right. So, this is not true. This is false. Okay, false. So notice that it can switch the truth value, right? Okay, next thing, let's do the inverse. So if you don't make an A, then you don't what? Oops, this is wrong. Sorry. Go back to inverse. Inverse only negates the original. So if you don't make a 90%, my bad, so sorry. You guys with me? Then you don't make an A. So if you don't make a 90, you could still make an 89.5 or 100 or a 97 and get an A, right? So just because you don't make a 90 doesn't mean you don't make an A, so this is false. Okay, last one, the contrapositive. Switch and negate. So if you don't make an A, then you don't make a 90%. So if you don't make an A, is it possible to not make an A and not make a 90? If you don't make an A, then you don't make a 90. That's true, right? Okay, so now notice it changed back to true. This is always the case. If it starts out true, the contrapositive will be true. These two statements will always have the same truth value. Your conditional and your contrapositive will always have the same truth value. If it starts out false, then the contrapositive will be false. If it starts out true, the contrapositive will be true. They will always have the same truth value. The ones in the middle will also always have the same truth value. Notice they were both false. That means your converse and your inverse will always have the same truth value. Okay, so the two in the middle, the converse and the inverse, they always have the same truth value. The original conditional, and if you switch and negate your contrapositive, always have the same truth value. They could both be false, they could both be true. Both be false, both be true. Over there, they were all true, so that didn't show it very well. That's why I wanted one that would switch. Are we good? Okay, those are called logically equivalent statements. And that should be the last definition that's in your notes here for 2.2. Logically equivalent statements. Logically equivalent statements are simply statements that have the same truth value. If two statements are both true, we say they're logically equivalent. If two statements are both false, we say they're logically equivalent because they have the same truth value. And then they remind you right here what I just said. A conditional and its contrapositive are always logically equivalent. The converse and the inverse are also always logically equivalent. Does that make sense? Okay, and that was the end of 2.2 in your notes, right? Okay, let's look at 2.3. Okay, this section is basically two laws and the difference between those two laws. And that's all that's in 2.3. It is the law of detachment and the law of syllogism. Law of detachment, law of syllogism. And then we're going to think logically and make some conclusions, okay? This is also where we define the word deductive reasoning, even though I already gave you the definition yesterday. This is where our thought process starts to think deductively a little more. So here is that official definition for deductive reasoning. It is the process of using logic to draw conclusions from facts, definitions, properties. You could add postulates, theorems, anything that is a given rule or fact. Okay? So watching someone walk in the room every day to see what they're wearing and then deciding they wear that every day, that is not deductive reasoning. That is inductive, based on patterns. That's what you turned in for your homework. You looked at the pattern. We're talking about deductive. That means it's a written rule. It's a fact. Two angles that add to be 90 degrees are always called complementary angles. That's a fact. Okay? All right, so they're going to ask you, and some of these are kind of tricky, to read through a statement here and decide, is this a process of thinking inductive based on looking at something that's happened over and over again, a pattern, or is it deductive that in that problem somewhere they've given you some written facts and their decision is based on those facts? Okay, there should be, how many in your notes? 3 maybe, let's see. Just 2. So you're going to do the next 2 problems, you and your partner, you're going to argue it out. Is it inductive reasoning or deductive reasoning? Let's check. So there's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July the 8th, September the 21st, and December the 19th. Therefore, the conclusion is the myth is false. Did they make their conclusion based off a written fact or on a pattern of observations? Patterns. So this is what? Inductive reasoning. Okay, the next one is obviously then deductive, since I told you one is each, but let's talk about why. It says there's a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above the Earth. The moon is about 237,000 miles from the Earth. Therefore, the myth cannot be true. Is there a pattern of events or are there written facts? Written facts. These are given facts. There is a picture taken. This is the distance of the moon. Therefore, this is false. So if it is a written fact, a theorem, a definition, a postulate, a given rule, that's deductive. If you had to observe something happening over and over again, then it's inductive. Is that clear? Okay, that will be on your test. Make sure you know the difference between inductive and deductive, okay?
Yeah.
All right, so now we're ready to get to our 2 laws that we have. The first one is the law of detachment. The second one is the law of syllogism. I'll show you in a second how you can tell very quickly the difference between the 2, okay? But first, let's read what the law of detachment says. The law of detachment says, if P implies Q is a true statement. So if you are given a conditional statement and it's true, okay? Then, if you're given that P is true, you can conclude Q is true. That's wordy, so let me give you an example. If you make 100 on your homework, then you get a sticker. True or false? True. I pass back your paper, you get 100. What can you conclude? That you're getting a sticker. That's the law of detachment. If you have a statement and it is a true statement, that's given to you, and then the first part of the statement happens, you can conclude the second part will happen. Does that make sense? Okay? The law of detachment does not go backwards. If you get a sticker, that does not guarantee that you made 100 on the homework. I could have decided to just give out stickers today. Okay? So it doesn't go backwards. No, I didn't do that. But I could. So key thing here is the arrow points to the right. It cannot go backwards. In other words, you cannot be given the end of the statement and conclude the beginning of the statement. Okay? So they're going to give you some series of situations here, and they're going to say, is this a valid use of the law of detachment? Meaning, did they do it correctly? If they gave you a true statement and they give you the first part happens, you can conclude the last part happens. But if they give you the last part happens, you cannot conclude the first part happens. Let's try it and see. So determine if the conjecture is valid by the law of detachment. So you're going to either tell me yes, valid, no, invalid. Here is what is given to you. If the side lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30 centimeters squared. Okay, that's your if-then statement. If the side lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30 centimeters squared. Then they tell you the area of the triangle is 30 centimeters squared. Okay, to help you a little bit, let's label our P's and our Q's. So what's the P part of this statement? Okay, the hypothesis, so all of this, the side lengths are 5, 12, and 13, that's P. What's Q? The area of the triangle, that's Q. Okay, so that is a true statement. Then they give you the area of the triangle is 30 centimeters squared. Are they giving you the P or the Q? The Q. They conclude that that means the side lengths of the triangle must be 5, 12, and 13. That's the P. So remember, the law of detachment says if you know P, you can conclude Q. But you cannot go backwards. If you know Q, that does not mean that it is P. So is this valid or invalid? It should be invalid because they gave you the Q and concluded the P. And you can't go backwards. And here's another way you can know. If the area of a triangle is 30 centimeters squared, then I could have a triangle where my base is, let's say, 20, and my height is 3. Area is base times height divided by 2, right? So this is 20 times 3 is 60 divided by 2 is 30. And is my side lengths 5, 12, and 13? No. I have a side length of 20. So that's why you can't conclude it this direction. That's why it's invalid, because it doesn't work. Okay, so one more time. They're going to give you a statement, if P, then Q. If they give you the P part, you can conclude the conclusion, the Q part. If they give you the Q part, you cannot go backwards and say then the hypothesis has to be true. Okay, let's try again. So this is invalid. So here's another one. Given. In the World Series, if a team wins 4 games, then the team wins the series. Okay, what's the hypothesis? Team wins 4 games. Okay, there's a hypothesis, so that's our P. And then what's the conclusion? The team wins the series. So that's the conclusion, or Q, right? Okay. Then they tell you the Red Sox won 4 games in the 2000 World Series. Did they just give you the hypothesis P, or did they give you the conclusion Q? Hypothesis P. So they're giving you P. And now they conclude the Red Sox won the 2004 World Series. Did they give you the Q? Is that the Q conclusion? So If P, then Q, that's true. They gave us P happens, so can we conclude Q happens? Yes, so this is valid. Mind your P's and Q's. I like it, yes. Are we kind of getting it or still a little confused? Good? Okay. That's the law of detachment. Here's the big difference between the law of detachment and the law of syllogism. The law of detachment has one if-then statement. If you go back and look at those examples, there was one if-then statement. Then they gave you the first part of the hypothesis, and you concluded the last part, the conclusion. The law of syllogism is going to have two if-then statements. It's going to say if P implies Q is a true statement, and then Q implies R is a true statement, you can come up with a third statement that would say P must imply R. Okay, so let me see if I can come up with a good example. If you make 100 on your test, you will get a math card. If you get a math card, you can replace a homework grade. Okay, so if you make 100 on the test, you get a math card. True or false? True. If you get a math card, you can replace the homework grade. True. So now let's combine those two if-then statements into a new one. P implies R. So if you make 100 on a test, that's what I said to start with. So if you make 100 on a test, then you get a math card. If you get a math card, then you can replace the homework grade. Okay, so if you make 100 on your test, then you can replace a homework grade. Does that make sense? In the law of syllogism, the conclusion of the first statement is always the same as the hypothesis of the second statement. Those are always the same. Because they're the same, you're basically just getting rid of them and combining the original hypothesis and the final conclusion. Are you with me? Let's try it. So you're going to decide, did they use the law of syllogism correctly? Oh, by the way, go back. It cannot go backwards. R cannot imply P. You cannot go backwards. Just because you can replace a homework grade, does that mean you made 100 on your test? No, maybe you had those 3 hall passes, or maybe you got up and sang the song and got a homework pass. So it does not mean you can go backwards, okay? All right, so let's see if we can do it. Given, if a figure is a kite, then it is a quadrilateral. Let's label our P's and our Q's. So if a figure is a kite, P. Then it is a quadrilateral, Q. Are we good there? Okay, if a figure is a quadrilateral, is that the same as where we just ended? So that is called Q again, right? If a figure is a quadrilateral, then it is a polygon. So this would be R. So see how we have if P, then Q, if Q, then R. So what we should be able to say is if P, then R. What we cannot say is if R, then P. Are you with me? So can we say if a figure is a kite, then it is a polygon? Okay, because this is P and this is R. Okay. They used it correctly. So is this a valid use of the law of syllogism? Yes, it is valid. Okay, let's look at another one. If a number is divisible by 2, then it is even. If a number is even, then it is an integer. Where's the Q's? What's the part they have in common? Okay, number is even. So if a number is divisible by 2, that's P. It is even, that's Q. Made that too big. If it's even, that's Q again. Then it is an integer, that's R. Do they do it correctly when they say if a number is an integer, then it is divisible by 2? No. They did R implies P, and we can't go backwards, so this is invalid. Making sense? Sort of? Okay. Here's what I want to warn you about. They won't always line up your sentences where the Q's are side by side. Sometimes they do this. They say, if Q, then R. If P, then Q. So what you have to do when you read that is you have to identify where's the parts that are the same, the Q, and then write your sentence the correct way. If P, then R. So on the homework, they may ask you to write a sentence using the law of syllogism, but they may not have them lined up side by side the correct way. Just rearrange them when you read them in your mind so that you start with if the part that's not the same, then conclude the part that's not the same. Does that make sense? Okay. Try this one on your own with your partner. So remember, your answer should be valid or invalid, right? Okay, what's the part they have in common? What's the Q that's overlapping? Mammal. So an animal is a mammal. It is a mammal. That's the part that's the same. So this is one of those instances where they've rearranged your sentences and they're not in the correct order that you're going to need them in. But I just always look for the part they have in common first. Q, Q. Then that means this is saying if an animal is a dog, P implies Q. If an animal is a mammal, then it has hair. Q implies R. Does that make sense? Okay, and then the part they have in common just cancels out. The Q's go away. So what you should be able to say is, if an animal is a dog, then it has hair. Is that what they said? So this is valid. Okay? Make sure that they don't go backwards. The key is just you can't go backwards, okay? The last thing that's in this section here is you have to come up with conclusions yourself using the laws of detachment and syllogism. So remember, it is if P then Q, they give you P, your conclusion is Q. Okay, that's the law of detachment. If they give you this and P happens, your conclusion is Q will happen. Okay? Law of syllogism says if they give you P implies Q, Q implies R, and P happens, you can conclude R will happen. All right, so you're trying to come up with the conclusion here. Draw a conclusion. So given, if 2y equals 4, then z equals -1. So this is our P and our Q, right? Maybe I have it labeled wrong. Keep reading. If x plus 3 equals 12, then 2y equals 4. So now we have a second if-then statement. Is this going to be a law of detachment or a law of syllogism? Syllogism. So let's go back. We have two if-then statements. We need to find the part they have in common first. What do they have in common? Okay, so that's really not P implies R, it's Q implies R. And then it's if P implies Q, right? And you don't have to put the P's, Q's, and R if that confuses you. Just get rid of the part they have in common. So this part and this part is what they have in common. So what you should be able to say is, if x plus 3 equals 12, then, nope, ignore that part down here. If x plus 3 equals 12, then Z equals negative 1, right? Okay, so now they're giving you something has happened. Sorry. Oh, I did it again. They're giving you that something has happened. So this is your first statement. This is your first statement. This is your second statement. This is what's happened. You have to come up with the conclusion. So we said, if x plus 3 equals 12, then z will equal negative 1, right? So they say, hey, x plus 3 equals 12. What can you now conclude? Z equals negative 1. Okay, I'm going to have to shut it down and restart it really quickly because I messed up by touching it. We'll write it down. I'll show it again if that confused you. So sorry. I know you guys are like, enough of this already. Who cares if P implies Q implies R? Oops, I don't need that one. I've got to figure out what it is when I touch that messes it all up. Someday I'll figure that out. Oops. 2, 3. Okay, I should be ready now. Okay, so one more time. Make sure you really understand. This is the part they had in common. This is the part they have in common. We just cancel that out. So now we can say, if this happens, then this happens. Okay? Then they tell you, this happens. X plus 3 is equal to 12. So you can conclude what? That Z is equal to negative 1. So this is different. This is just saying, what is your conclusion? What conclusion can you make? If these two things are true, we could conclude that Z equals negative 1, and then they tell us the first part is true. So now the last part has to happen. Let's try the last one. Read it and tell me what is the part they have in common. What's the same? Okay, are we seeing the part that's the same? Okay, the angles are supplementary. So what I usually do is just get rid of those. Again, you see two if-then statements, right? So we're still dealing with law of syllogism. So if the sum of the measures of two angles is 180, then the angles are supplementary. If two angles are supplementary, then they are not angles of a triangle. So we can say if the sum of the measures of two angles is 180, then they are not angles of a triangle. Agreed? Okay, so then here's what they give you. This is the given part. Measure of angle A is equal to 135 and the measure of angle B is equal to 45. So when you are given that information about two angles, is the sum of the measures of two angles 180 when you look at the two angles? Yes. So what can you conclude about these two specific angles? They are not angles of a triangle. So you can say angle A and angle B are not angles of a triangle. Because what do all three angles in a triangle have to add to equal? Do you guys know? What do the sum of three angles in a triangle have to equal? 180. So there's no way if you have two of them that already add to equal 180 that they could be the angles inside of a triangle because you wouldn't have enough for a third angle. Okay? Is that making sense? Okay. There's one more example in your notes. Let's see if it's the same. Yeah, it's the same thing. So I'm going to stop there. Are we good with this idea? All right. 2, 4. How about we take a 2-minute break, stand up, wake up, and today's a good day for a piece of candy. Mm-hmm. Well, I'm shoving a lot of stuff down your throat today. Oops. Yeah. I have more in the back if you need me to fill it back up. If there's something you're wanting that's not there now. Do you want me to go fill it up real quick? Okay. Okay, now guys, see if there's something you want.
Yes. I don't know what I want. There's so many options. What's gonna last me the longest?
A sucker.
Yeah,
What
probably a
flavors
sucker.
are there?
Wait.
There's grape, there's apple, there's a strawberry. Is there a certain kind you're looking for?
Watermelon.
I don't think I have any. Is there? Oh, is that watermelon? Yes. Okay. You're welcome. Tyler, did you get something ready? Javi, did you? Okay. Girl, it's over here.
Thank you.
You're welcome. Oops. You sure? Okay. Okay. Did I get everybody? Okay, last section 2-4. Everything's a little better with some chocolate or candy. 2-4 is where we learn our fifth kind of statement and some few basic vocabulary words that you should already know. So our fifth kind of statement, we've got conditional, converse, inverse, contrapositive. Our fifth one is the biconditional statement. Biconditional. Okay? Biconditional is probably the most important one for proofs because all of your definitions are going to be biconditional statements or can be written as biconditional statements, and that's what they're going to talk about in this section. And I'll explain when we talk about what is a biconditional statement, why that's so important, okay? So here is your definition for biconditional. A biconditional statement is a statement that can be written in the form P if and only if Q. Okay, P if and only if Q. In other words, hypothesis, if and only if, conclusion. Okay? Yes, I will. 1 second though. We are not going to write it any other way, and they give you lots of other ways you can write it, but you are going to write it for me, P if and only if Q. Okay, so you can ignore everything else that they talk about as far as symbolic and notation. We are writing it as P if and only if Q. So over here on the board, where we had if P then Q, if Q then P, blah, 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 you do not start with the word if. You start with P. So it is P if and only if Q. Okay? Biconditional symbolic notation, it goes both directions. That's what that means. So it means P implies Q and Q implies P. It goes both directions. So when you write it, you draw a double arrow. P with arrows pointing both directions, Q.
Wow, that's
Very good. Yes, it does. So it is a line. So here's my example. If they're both true, you can write a true biconditional. So sometimes you can write a false biconditional because they're not both true. What I mean by that is your conditional has to be true and your converse has to be true before you can write a true biconditional. So we could not combine these to write a true biconditional. Okay, but we could combine our sentence that dealt with the spider. Let's try to combine our sentence that we wrote earlier about the raining first. So we said if it is raining outside, then the ground is wet, right? Biconditional would say, it is raining outside if and only if the ground is wet.
Also, you have to have if and only.
If and only if is in there, just like the words if and then are in there for the conditional statement. Okay? Now that's not true because the ground could be wet even though it's not raining. Somebody could have just poured water on the ground. Like, there'd be lots of reasons. But let's go with the spider thing. It said if an animal is an adult insect, then it has 6 legs. The converse says if it has 6 legs, then it is an adult insect. Those were both true. So biconditional would say an animal is an adult insect if and only if it has 6 legs. Okay? Or we could go over here and write a false biconditional. This would not be a true one. You make a 90% if and only if you make an A. But that's not true, right? Okay? So you can write a biconditional and it turns out to be false if they're not both true. So make sure they're both true. Okay, so once again, this is your notation for biconditional. We are not going to write it any of these other ways. We are just going to do P if and only if Q and then our symbols. Your homework may ask you to use symbolic notation. That's these little arrows with the P's and the Q's and the little squigglies. Okay, that's symbolic. And then if it says write it, then you're writing out in words, whatever it says. Okay? So, let's try to do this one together. So it says write the conditional statement and converse that is within this biconditional. So this is going backwards and breaking it apart. Read the sentence first and tell me, how do we know this is a biconditional? How do we know when I read that it is a biconditional statement? Okay, when you see that if and only if, it is a biconditional statement. Always. Okay? The part that comes first then is your P. The part that comes after it is your Q. P, if and only if Q. So this is a biconditional statement because it says if and only if. Now, I should point out, you might see something in textbooks, whether it's this one or future books, where they do this. Okay. It's not a typo. It's not if. It means, I know. Yeah, if. No. It is just, it means if and only if. It is a shortened way of writing it. You are not writing it that way, okay? You're going to put if and only if. But if you see that, that's what that means. Okay, so this is biconditional. They want you to write the conditional, and then they want you to write the converse. So the conditional says if P, then Q. The converse says if Q, then P. So you're going to write it for this sentence. So let's start with the conditional. And on your homework, make sure you identify which one is which. So conditional and then converse. Don't just write sentences. Make sure you identify which one's which. So what would the conditional say? If an angle is obtuse, then its measure is greater than 90 and less than 180. Good. So if an angle is obtuse, then its measure is greater than 90 degrees and less than 180. That's a lot of writing, right? What's the converse going to say? Very good, Karina. So notice that she did not start with if it's. She said if, and she went back and identified her subject first. So if an angle measures, or if an angle's, measure is greater than 90 degrees and less than 180 degrees, then, make sure you're putting those keywords if and then, it is obtuse. So all we did was take the biconditional and just split it apart. Okay? They may give you these two and ask you to combine them together and write the biconditional statement. If they do that, all you do is get rid of the word if, get rid of the word then, and in between you put what phrase? If and only if. Okay? It's easy, right? Because we had to learn the whole what does if then mean. All right. If. Yes. Okay, can we just talk this out loud without writing it all down? Just kind of go over this one?
Yeah.
So notice the if. That's your if and only if. So is this biconditional? Okay, so what would the conditional say?
If an angle is acute,
Exactly. And what would the converse say? Very good. So I think we were getting that. I'm going to move on. Bless you. Bless you. I think you got it. Okay, so this one gives you the conditional, wants you to write the converse and the biconditional. So again, let's see if we can just say it out loud without writing it down. I'll send these notes out. If you need the notes, you can look at them at the link, on the link, okay? So this is the conditional. What would the converse say? Somebody volunteer to read it for us. So for this conditional, write the converse. So what would the converse say? Okay, go ahead. One more time, Ridley. Okay, so notice she is writing the converse, so she's switching, but she didn't start with if they. She went back and said, what are they? They are the points. So she said, if the points are collinear, then she can throw in the word they, lie on the same line. Are we good with converse? Okay, now let's write it as a biconditional. So then it says and a biconditional. So on your homework, you would have to do both. But again, we're just going to read it instead of writing it all down. Biconditional, what would it say? Alexis? Perfect. Biconditional just deletes these two words, adds in your if and only if. But you're not going to put IFF.
So you could just start off with the points and then go from there.
Mm-hmm.
So you don't have to go.
Does that make sense? Okay. All right, so this is super important. I already said this, but I want to point it out here. For a biconditional statement to be true, both. Is this not written on yours? Yeah. Okay. Do you see it? Did you find it? It's right there. Right there. I think. Did we? Sorry. Okay. For a biconditional statement to be true, both the conditional and the converse have to be true. If one of them is false, then your whole statement's false because it can't go both directions. So your conditional has to be true and your converse has to be true for the biconditional to be true. Does that make sense? Okay. All right, so let's see if this is true or false. It says determine if it's true or false. If it's false, give a counterexample. A rectangle has side lengths of 12 and 25 if and only if its area is 300. So what you're going to ask yourself is it true going this direction and then switch the direction and go backwards? Is it also true? So if a rectangle has side lengths of 12 and 25, is the area of the rectangle 300? So is 12 times 25 300? It is. Length times width, 12 times 25 is 300. Okay? So it's true for the conditional, right? Okay? Now go backwards. If a rectangle has an area of 300, do its side lengths have to be 12 and 25? No. What would be a counterexample? 10 and 30. So you could write and draw yourself a picture of a rectangle with your side lengths of 10 and 30, centimeters, circle it. It is false, and this is your counterexample. Your counterexample, remember, it can be a picture, a number, or a statement. Okay. So again, it has to be true both directions for the whole entire biconditional to be true. So try it both ways and see. Does that make sense? Okay. Decide if that's true or false. If it's false, give a counterexample. Oh, I'm sorry. Start here. Then go backwards. Okay, true or false? An angle is a right angle. If that's true, it does have a measure of 90. If an angle has a measure of 90, then it is a right angle. So this is true. And this is an example of the last part of the notes. This is a definition, right? A 90-degree angle, its definition is it measures, or a right angle's definition is it measures 90 degrees. So every definition can be written as a biconditional statement. Every definition goes both directions. So when we're doing proofs, if they give you that you have a 90-degree angle, you can say that you have a right angle. If they tell you you have a right angle, you can conclude that its measure is 90 degrees. And so that's super important when we get to proofs, because you're going to have to decide what can I conclude next. And if it's a definition, it goes both directions. Okay? All right. This one's the tricky one, so I want you to look at it really quickly with me. Determine if it's true. If false, give a counterexample. Okay, so first direction would be if y is negative 5, is negative 5 squared 25? Okay, so that's true, right? Okay, let's go the other direction. If y squared equals 25, does y have to equal negative 5? No. What could y be? Positive 5. So this is false, and your counterexample is y equals positive 5. Does that make sense? And that goes back to Algebra 1, that when you solve with square roots, you can have plus or minus. All right. Good. Okay, the last thing in your notes are some basic definitions that you should already know, and the definition for the word definition. Definition for definition. A definition is simply a statement that describes, in our case for geometry, mathematical objects, and every definition can be written as a true biconditional. So a definition is just a statement that describes your mathematical objects, and they always can be written as a true biconditional. Some definitions you should already know. Polygon. This one's huge. Polygon means, poly means many, gon means sides. A polygon is a many-sided figure. Okay? Polygon definition, we're going to come back to this over and over throughout this year. For it to be a polygon, it has to be closed. It has to be two-dimensional. Plane figure means 2 dimensions. It has to be formed by 3 or more line segments. No rays, no lines. And I'm going to add, they have to intersect at the endpoints. They don't put that here, but that is a very important part of the definition. They must intersect at the endpoints. So do you see that these are all polygons on this side? These are not polygons over here. This one's pretty obvious. It's 3-dimensional. This one's not closed. This is not intersecting at the endpoint. This does not have all segments. It's got curves. This one, it's because it's 2 polygons put together. It's not just one polygon. They're intersecting at points on those segments instead of just the endpoints. Okay? And then the last definitions that you should have in your notes is what is a triangle and what is a quadrilateral. And I hope you know that a triangle has 3 sides and a quadrilateral has 4 sides. And they are all polygons, right? Yes. Okay.